Good morning, pilot teachers and students, and good morning, class.
Good morning, Mr. Sarah.
Okay, thank you. You may sit down. Okay, in our last lesson, we studied something on pressure, and looking at pressure, the pressure especially on solids. Okay. Now, in this lesson, we'll be looking at pressures especially in liquids, and we will also see how you can derive a formula in calculating pressure that exists in solids. Okay, you know what pressure is. Pressure is the force that is applied per unit area, or force per unit area. So in this lesson, we will now have a look at pressures in fluids or in liquids. All right, for the first one, you will find that especially when you study weight, you know that any object or body must be forced to move towards the center by the force of gravity. Now in this case, you find that it also happens in liquids. Okay, gravitational forces try to pull a liquid downwards, especially in that container, and this causes pressure on the container and pressure on any object put into that liquid. Now the following 4 important points applies to any liquid. So what you can do now is to quickly go through this main information. I will give you the 4 important points that applies to that liquid. So quickly have this one done, and then I will give you the liquid, rather the 4 important points, and also a diagram that explains each one of those points. Okay, I will now give you the first point about this pressure in liquids. all liquids under pressure pushes in every surfaces in contact with, right, no matter which way the surface is facing. All right, number one point about liquids is that they have to act in all directions. Okay, this picture shows you, especially because the pressure is forcing outwards on this the bottom of the boats. That is the reason why you have to see them simply floating. But as you can see in a real container, you'll find that, right? Let's say, for example, this is a container. Okay, you will find that the pressures will be acting in all directions. Okay, this is the first important point about any liquids. If this is a container, then you will find that the pressure will be acting in all directions, whether it is to the left, to the right, left, or down. Okay. So you can just have that point, number one, pressure, all directions. Number two point, okay, you'll find that the deeper you go into any liquid, or let's say if it is water, okay, if you are swimming and then you swim deep, you'll find that the pressure will be quite high as you go deeper. So that is the reason why, especially when dams are built, all right, they have to have a much more thicker base, okay, because pressure is quite high below. So in order to withstand that high amount of pressure, the base must be thick enough to withstand that pressure, okay? So have this point, I'll show you a diagram of a dam, not a diagram, but a picture, okay? And then I'll give it a third most important point about liquids. Okay. Okay, that is the information to the second important point, and that is pressure increases with depth. Okay, the information has been given to you earlier, right? This is just all right, this picture is an example of a dam, and you find that especially in a dam, the base, which is down here, the pressure will be quite high, okay? Pressure will be quite high at this point. That is the reason why base will be much more big enough to withstand that pressure. Okay, we'll go on to the next. Okay, that is trying to explain something on density. If you have a much more less dense object, the pressure will be quite high or low. Okay, it will be quite low because of the less dense liquid. But if the liquid was more dense, then the pressure will be high. So pressure depends on density as well. Okay. That is a third point. Pressure depends on the density of the liquid. All right, this is a picture of the sea. All right. Sometimes you find that the pure water and also the sea water have their own densities. Okay, so if they have to have their own densities, then probably the lighter one will have less pressure, while the more dense one will be having more pressure. Okay, so it can be the other materials such as, not material, but the liquid such as the fuel, can be kerosene, petrol. Okay, each one of these have their own densities. The lighter one have less pressure. All right, to the fourth. Pressure does not depend on the shape or the size of the container. For example, if you have a very strange looking container and you decide to pour water in, you will find that each one of those will be at the same level if you decide to put the same amount. So it does not depend on the shape of the container or the size. Okay. Okay. Let's say this one is A, that B, C, and D. So in this case, pressure does not depend on the shape of the container, right? So you have different shapes of the container, the level will be the same. Okay, that means pressure is the same in all these. If that shape of the container is irregular, we can still have the same pressure. Okay, very good. So, pilot teachers and students, I will now give you the activity questions. You can go through, copy those questions, and I will give you some time to do those questions. After that, we will discuss. Okay. Before that, we can go through. I'll just give you how we can derive or how we arrive at the formula, which may be asking you to find the pressure. Okay. Firstly, okay, you can copy this one after my explanation. Okay, I will explain based on that. Okay. You were given the formula, especially in liquids, pressure will be equals to density times the acceleration due to gravity times the height. Okay, you were given like this. But how did you arrive, or how can you derive that? Right, if you have to look at that, simply if you want to calculate the volume liquid, it is simply the area in which that liquid, or let's say the container in which that liquid is placed. So that container must have the area times the height. That is how you can calculate the volume, which is area times height. But again, when you were discussing density, you were given a formula which is density equals to mass over the volume. Okay, density equals to mass over volume. This time you were trying to find the mass. So it will be mass equals to density times volume. Okay, this volume is taken from this one. Now, when you go further, you are not trying to calculate the force. Okay, force is given as density times, okay, gravitational acceleration. So that is force, which is equals to mass times acceleration. Force equals to mass times acceleration, and in this case you are given the mass as density times area times height, and this G now comes in. And then when you want to find the pressure, pressure equals to, okay, this density times acceleration times area times height. That is the force. But this time, when you want to calculate pressure, pressure equals to force over the area. So force, when you include this, it will be density times, okay, times A times height. Since it is pressure equals to force over area, okay, this force here, force equals to, and then when you cancel this one, you arrive with pressure equals to density times T times H. Okay, so that is how you can, or the formula is derived. So you can go through and then copy each one of those steps quickly, and I'll give you some activity questions. Okay, I think you are finished now, right? Just based on this explanation, you can, that is how the formula is derived. Okay, for the first one, volume equals to area times the height, or let's say the depth. Okay, that is for first, if you want to find out the volume. Right, using that volume and using the formula as density equals to mass over volume, we can now calculate the mass, which is density times the volume. So mass equals to, okay, density times the volume, or which is simply density times area times height. And then given the weight or the force that is exerted by that liquid, we can simply have mass times acceleration. Okay, that mass is taken from density times area times height. So when we have that force already, we can simply calculate the pressure, which is equals to density times acceleration due to gravity times area times height over area. Okay, now when you cancel those two ways, you come up with pressure equals to density times, okay, 10 is a factor in there, which is given by that formula. All right, I will now give you the activity questions. There are only 2 questions. Pilot teachers, you can also ask students to go through copy these 2 questions, and I will give you some time to complete, and we can discuss those 2 questions. All right, question number 1. Okay, number 1 question: to calculate the pressure exerted by the tap of 5 meter in a fluid of density 1,000 kilogram per cubic meter. All right, that should not be odd, but it should be off. By now you should have finished copying that question. Now we'll move on to question number 2. Okay, here comes question number 2. Quickly copy those questions, that question. Right, for question number 2 here, you have 2 questions. Basically, it's asking you to calculate the pressure and also the force or the thrust force on the base of the tank. Right, number 2, question number 2 reads, a tank of 4 meters long and 3 meters wide is filled to the brim with paraffin. Okay, it has a density of 800 kilogram per meter cube. You are now asked to calculate the pressure at the base and the thrust force on the base of the tank. Okay, you work on those questions quickly. Okay, should be minus 3. Okay. At least a little bit of information. Mistake here. This one should be minus 3. Okay. Okay. Enara, question number 1. Question number 2. Let's see who is it today. Rolling. Can you tell our friend there? Mark, Alan Mark. Yeah. Question number 2. No, Mark. Alan. Question 2. Question 2. And you just send out to answer question 2, the last one on the base of the tank. Question number 2, he's going to do the first one. You can find it there, 2 sets of questions. Calculate the pressure at the base and the thrust. So you give us the answer to the thrust. Yeah. No. Okay, looking at this one, the tank of 4 meters long and 3 meters wide is filled to the brim with paraffin. Density is 8,000. So you asked to calculate the pressure. Pressure equals to density times mass times the density times T times height. So in this case, the area is given as is only given, probably it's at 4 meters long. Yeah.
This area is 4 meters long and
Yeah.
4 meters wide, and the depth is also 4 meters long.
Yeah. So what do you think? Okay, you were trying to answer your own question. So if the after the force is going down, there must be always the opposite force that is always upwards. So the thrust would be almost equal to the force that is acting downwards. The thrust is always acting upwards on the liquid. Okay, you know the upthrust force. Okay, if the tank of 3 meters long and 3 meters wide is filled to brim with paraffin. Okay. The question in this one, you only see the base which is given as 4 and 3. Okay, the height should be about 4 meters. Okay, the height should be 4 meters. Bien. Mi lo que la correction lab. Bien, but me go type so 4 meters inside so inside. This layer mid type no. Okay. First one, the height should be 4 meters. You have base which is 4 and 3 times 4, which is the height. Okay, shall we have the answers to question number 1 and 2? Get up there. Question number 2 will be Mark. Come. Okay. The height should be 4 meters. The height for that question number 2 will be 4 meters. Okay. Area is 4 times 3. Yeah. The height should be 4. Okay, pass him that.
The formula, pressure equals density times gravitational force times the height. So for the density, which is 1,000 kilograms per meter cube, times gravitational force due to the gravity, it's 10, times the height, 5, and this is my answer, 50,000 pascals.
Okay, 50,000 pascals is the answer. That is for question number 1. Okay, for question number 2. Question number 2 will have Alan. You stated it doesn't correct.
The force on the base or the upthrust, if you want to get the force, multiply the density times the gravitational acceleration due to gravitation, and the area times the height, which is 800 times 10 times 12 times 4. That will give you 384,000 newtons. That's the force. And to find the pressure,
Mark.
pressure you just multiply density times gravitation times height. Gravitation times height, which is density is 800 times 10 gravitation on the earth, and times by 4 the height. That will give you the pressure 32,000 pascals.
Okay. This one should be 32 pascals. Okay, that is the pressure. Okay. Now we've just gone through looking at pressure in liquids, and there are basically 4 important points that you should know. Pressure acts in all directions. That is the first important point about liquid. Number 2 is that as you go deeper, pressure will have to increase. And also, third point, which is pressure depends on the densities. So if a lighter, let's say, less dense liquid, it will produce a pressure which is quite less. So high density liquid have high pressure. And fourth point, pressure does not depend on the shape of the container. Okay, any shape must have the same pressure. Right, so you have seen how you can derive the formula for calculating pressure in liquids. That is density times acceleration due to gravity times the height. Okay, simply working out from the volume mass, which comes from the formula for density, and then using that you can now calculate the pressure, especially that is exerted in liquids. Okay, even if you are given the densities of that liquid, or if you are not given densities of that liquid, using the formula you have now, you can now calculate the pressure, especially in the liquids. Okay, in our next lesson, we'll be looking at especially pressure in, let's say, hydraulics. Okay, that is what we'll be looking at. Our keyword for today will be okay. The keyword is pressure in liquids. Okay. Good afternoon, pilot teachers and students, and good afternoon, class. All right, thank you. You may all sit down.